Last class, I discussed few definitions and I explained with examples. So let us discuss operations and some of the formulas in this video. Here, union of two sets is defined as, for unions, representation of union is with symbol U. How it is defined, X belongs to A or belongs to B or belongs to both A and B. So meaning of it, so this is A belongs to A means only A or only B or belongs to both A and B. So here let us see one example. Set A contains 1, 2, 3. Set B contains 1, 2, 4. And how do we find union? It belongs to A, belongs to B or belongs to both. Here one is represented with circle A, other is with B. A contains your 1, 2 are the common elements. So it belongs to A, belongs to B, and belongs to both. Intersection is represented with this symbol. So here, how it is defined, it should belongs to both A and B. So that means here, this is A, you have to find out the common elements of both A and B. Let us take one example in the listed format 1, 2, 3, 4. B here is 5, 6, 3. Intersection means common element. Common means your only element which common to both the sets is 3. So difference of sets. How difference is defined? Represented with A minus B. Element must belongs to. If I say X belongs to A minus B means X is in A, X should not be in B. Meaning of this, so it should belongs to A, not B. That is simply nothing but only A. If I say A has 1, 2, 3, 4, B has 3, 4, A minus B will be except 3, 4. That is 1, 2. So let U be the universal set. Then difference of U and A is defined as complement and it is denoted by this. If you take, for example, this as universal set U, this as A, A complement means outside A, shaded part. So that is, for example, U, if I defined it as 1, 2, 3, 4, A, if I consider 1, 2, A complement will be U minus A. It should be there in U, it should not be there in A. That is 3, 4. Disjoint sets, when do you say two sets are disjoint? So representation of Venn diagram with circles. Two sets are said to be disjoint when they have no common element. Like AB, there is no common part, we say they are disjoint sets. Let us say K as 1, 2, B as 3, 4. A intersection B will be empty set. There is no common element. So it's also denoted like this. Overlapping sets means take this as one set, other as in the set. So if intersection is not empty, means there is some common elements. These two sets are called overlapping. Suppose A has 1, 2, 3, B has 3, 4, 5. We have 1, 2, 3, B 3, 4, 5. So this intersection will be contains only one element 3. One element is there, means it's not empty set. These type of sets are called overlapping sets. So symmetric difference is denoted by A delta B. Geometrically, A is this with representation of Venn diagram. And diagram is simply representing sets with circles. It is A, it is B. A minus B means it should be there only A, and B minus A means it should belongs to only B. This is shaded part. This part we write it as A minus B. This part we write it as B minus C. Union of these two will be symmetric difference. Suppose A has 1, 2, 3, 4. B has 2, 3, 4, 5. A minus B here is, so it should be 1. It should belongs to A and it should not belongs to B minus A will be, it should be belongs to B and it should not. 2, 3, 4 are there in both ends, so 5. It should be belongs to B and it should not belongs to A. So A minus B union B minus A, which is denoted with, which is here 1, 5. Commutative law means with respect to, generally commutative law with respect to star, some star in the sense some operation. Star can be plus, minus, division, any symbol. But with respect to union, if order, if you write A 1, 2 or 2, 1, there is no difference. So here, if you write A as 1, 2, 3, B as 2, 3, 4, A union B is 1, 2, 3, 4, which is same as B union A. Similarly, A intersection B is 2, 3, which is same as B intersection A, which is also similarly symmetric. So associative law means if you consider three sets, A union B union C means it covers all three sets like this. So whatever may be the order, A union B union C, obviously same as A union B union C. Right? A union B union C is entire or present in A, present in B, present in C, present in A and B, present in A and C, present in B and C. So here the first one is satisfies, we say it is set satisfy associative property with respect to the operation union. Similarly, A intersection B intersection C, if you consider. So then here it is what this with respect to Venn diagram. A intersection B means this part. Intersection with C. So common part of all three sets will be this. Whether whatever order you take, A intersection B intersection C or A intersection B intersection C, finally this common part, right? So it will not satisfy, associative property is not satisfied with respect to operation minus what this geometrically, this here if I say A minus B means this part minus C. A minus B is in A, it should not be in B as well as it should not be in C, only this shaded part, right? So A minus B minus C. Well, if I take some other three circles, so this part here is this A minus B minus C means, say this is A, B, C. B minus C means first this part, A, right? B minus C means this. Only B other than C. A minus B minus C means other than B minus C. So here B minus is this other than this. So there is a difference. They cannot be distributive law here. A union B intersection C. B intersection C is this part. A union means so now I can write A intersection A union B means A union B is this. Again, A union C means this. The common part where horizontal lines and A union common part horizontal and vertical lines are covered in this as well as this. Outside this, only here vertical lines, here horizontal lines. So these two are equal. Similarly, with respect to intersection, right? So De Morgan's law is very useful law, future point of view, higher studies point. Here it is A. This is universal set. A, A complement means outside B. Similarly, A union B complement means this is A, here it is B. A union B complement means outside those two circles. What about A complement intersection B complement? If I take this as A complement will be outside A. And here B complement means outside B. Outside B means so where horizontal, this is the intersection in common part, horizontal and vertical. That is A complement intersection B complement is same as A union B whole complement. Similarly, complement is there, union changes to intersection, intersection changes to union. Here minus is there, union changes to intersection. Where minus intersection is there, it changes to. Here idempotent law for any set A. So idem means same. A union A will be A only. A intersection A also same. Union or intersection. For any set A, you are see for set if you assume 1, 2, you are not adding anything, it becomes one count. So A union phi is A. So here it is. Identity law means universally for all sets. Union means this entire rectangle A here. Intersection will be for A and U. Obviously, A is a common part. Right. Principle of duality. What it says, all the